Soul coded.
All right. All right. Hey, hope you enjoyed the break. Are you enjoying the conference so far? Nice. Thanks a lot. It's awesome. It's really awesome. Next point on our schedule is lightning talks. And let's just dive ahead into it. First one is Nils. Give him a warm welcome. We need a moment to full screen it.
Okay. Okay, thank you. Hi, I'm Nils. Hi, I'm Nils. It's a timer running. Okay, I start then. I have a few seconds more than the others. 1 minute is a little bit. Yeah. Okay, thank you. Yeah, I will talk about embedded software here a little bit. I'm an embedded software developer, and I also do web stuff. So it's two very different worlds. So I learn in each world what I can do to make it better from learning from the other world. Yeah, so that's my question. What can we learn from each other? First question, what is embedded software? In my understanding, I think it's everywhere today. These are two projects I've contributed to. The car, I think it has 50 or 60 control units. I made software for one of them. The Airbus, I don't know how many control units are in there. I made software for one of them. Yeah, so what are challenges for embedded software? First thing, embedded software is stuck in the 90s. So we are working there like, yeah, you've worked 20 years before. One point is, most times you don't have the target hardware when you should start coding. So many people say, I don't have hardware, I can't start coding. That has impact on the schedule, as you can imagine. Test-driven development, it's not known or used very much. There's one book about it, I think it came out last year, and it's a very good book, and I've read it and I tried to implement test-driven in the embedded world now, but it's complicated. The tools are old too. Next point, safety critical systems. As you saw before, planes, it should not crash better. You have to do lots of formal work, lots of documentation, lots of verification. Things in other domains we skipped it and said we are going agile, we do the documentation that is needed, but we don't need that 100% verification everywhere. So on the one point we want to get more agile in the embedded world. On the other point, we have to fulfill these safety requirements. Last point, failures can result in disasters and tragedies. What you see down there, it's embedded software rocket science. It's one of the remaining pieces of the Ariane 5. It crashed 30 seconds after start. The engineers took software from the previous model, Ariane 4. They made a small bug in a floating point conversion, and that caused the rocket to crash. No one was hurt, but it cost $300 million, I think. A quite expensive software bug. So what to learn? Modern programming techniques is one point what embedded software can learn from the web world. Even when we have to use old programming languages, we can use the modern techniques. Solid software craftsmanship, it's mostly a peace of mind how we code. Just because you can anything in C, you don't have to. Test-driven development. When you take the correct approaches, how you code C code, then you can use test-driven development. It's no problem. When you have test-driven approaches, you can go one step further and use continuous integration. So your local test cases can be run automatically. Then you can buy cheap hardware and make a little more effort in integrating it in Jenkins, and you have a hardware-in-the-loop test suite. It's not much, no big effort to do it, but it really helps. In the last project I'm working on, it's a gas measurement system where real lives are depending on it. We've implemented it. We are using test-driven development in C, and we are using a Jenkins server that integrates our hardware-in-the-loop tests. So it's possible, I think, but most projects I've seen, they don't use it. I don't know why, but we should do. On the other side, modern web development, it's modern, but what can we learn from the past? First thing, that we are here now, it's for good reason. Some people said what we are doing is not good, so let's make it better. That happened, so now we have these modern tool chains and so on. Be grateful that you have it and can use it. Last thing, be a little paranoid. So how many of you can exactly tell how many software layers run between your web application and the hardware below? Do you even have direct hardware access, or do you have virtual machines or whatever? So just have a look inside and know what happens. You don't have to know each bit personally like you have in an embedded system, but something more like, oh, I've downloaded it and I've read a tutorial and seems to work, okay, next. Sometimes it helps to have a little look inside. Yeah, last thing, be grateful that you have the tools you have. You left the dark ages behind. So that's it. I think 6 minutes is okay. Next one.